Alright, so let me introduce Compute Engine, which is infrastructure as a service offering from Google. So GCE enables Linux and Windows virtual machines to run on Google's global infrastructure. You can launch a virtual machine, a VM, running either a flavor of Linux like Debian or Ubuntu or CentOS, or specific version of Windows as a virtual machine, and start managing it within Google Cloud. It gives you a lot of control because you primarily own the VM and you become the administrator when you SSH or RDP into the VM. So virtual machines are based on certain machine types. And what defines these machine types? Obviously the configuration. So the configuration depends on two critical parameters. One is the number of CPU cores and the other one is available memory. You can start with a very small VM which might even give you shared VPU or virtual processing unit cores, vCPU, and go all the way up to a bare metal machine, which is actually not a virtual machine but a fully dedicated machine. So there are a lot of configuration to choose from depending on the characteristics of your workload. If you are running a very simple prototype of, let's say, Python Flask application, you might want to start with an F1 micro, which is the cheapest and the smallest VM. But if you are running something in production, you might want to choose a slightly powerful VM, maybe with 8 cores, 64 GB of RAM, and maybe multiple such VMs put behind a load balancer. So depending on the characteristics of your workload, you will choose the right configuration of the virtual machine. And Google has a pretty wide diverse range of VM families and configurations available for you. Now VMs by default don't offer persistence, which means if you install a database in a VM and you terminate the VM, you lose the data. Because everything that is created within the VM is transient in the sense. It gets deleted and gets terminated and become unavailable the moment you terminate or deprovision a virtual machine. So how do you bring durability to VMs? By attaching an external disk called the block storage, and that brings persistence. So when you attach a block storage device like a standard disk or an SSD disk to a virtual machine, it becomes a newly available partition or a new device, a storage within your VM. And you can use that to store your data files or anything that need to live beyond the life of the VM. So now when you terminate the VM, the data is still available in the persistent disk, and when you launch a new VM, you have the choice of attaching the same old persistent disk to bring back the data. So this is how you can separate the VM from durability, persistence based on external storage, which is also called block storage. And VMs are charged at a minimum of 1 minute and in 1 second increment after that. That means if you launch a VM and terminate it within, let's say, 40 seconds, it will be rounded off to the nearest 1 minute. And if you are continuing to run it beyond 1 minute, you will be charged on a per second basis, giving you a very fine-grained approach to calculating how long your VMs are running. So this gives you a chance to optimize your VM provisioning and how long you want to keep the workload running. In an auto-scale environment where VMs are automatically launched and terminated, this is very, very efficient because you only get billed for the duration of that VM. And that too, it's not rounded off to an hour, it is rounded off to a minute, and after that it is 1 second increment. So it gives you extreme flexibility in terms of scaling and running your VMs. The more you keep the VM running, the better the cost is going to be. So Google has an offering called sustained use discounts. So if you continue to keep a VM running for a full month, you actually get a discount because there is a sustained use of the VM. So it automatically gets supplied and your VM will have different billing based on the discount offered through sustained usage. Now this is very unique to Google Compute Engine, It's not available in other cloud environments. So sustained use discounts are a pretty unique way of charging you for the compute that you run. The longer you keep the VM running, the better the discount. You can also use what is called as committed use discounts, where you go ahead and commit to Google that you are going to run this VM for a period of 1 year or 3 years. So you essentially sign a contract. And because you are committed to paying Google for a longer term, in a period of 1 year or in 3 years, you actually get a committed use discount. So instead of a on-demand pricing, you get a better pricing because of you have committed a certain period of running this VM with Google. So that it's almost like signing a contract. Even if you are not utilizing the VM, you would still be charged because you committed to run that VM for a longer time, for a period of 1 or 3 years. So it doesn't matter whether you are keeping the VM running or you have stopped it or terminated it, you will still be billed because it's a part of committed use discounts. If you don't want to do that, you can always go for on demand, where the billing starts after 1 minute, rounded off to the nearest 1 minute, and then 1 second after that. So that is committed use discount. So the summarize, GCE give you infrastructure as a service in the form of virtual machine running Linux or Windows. You can launch them through on-demand mechanism, or you can go for committed use discounts, where you sign a contract and commit to use this VM for a period of 1 year or 3 years. Within on-demand, you can still claim sustained use discount for keeping the VM running for a longer time, and a VM is configurable based on the amount of RAM, amount of CPU cores that you need, and you can bring in persistence by adding an external block storage device.